When we're looking at distances in space, or we're talking about anything in terms of astronomy, we have to have ways of discussing how far apart things are, especially since the distances are so vast. And so, one of the first things that we have is when we're talking about within our solar system, which we're going to spend the next couple of days doing. Within our solar system, we measure our distances with a unit called astronomical units. Okay. And one astronomical unit is approximately equal to the average distance from the center of the sun to the Earth. And that represents about 150 million kilometers. So it's a large distance. And when we have large distances, it's hard to keep track. But that allows us to say the distance from the Earth to the sun is 1 AU. And then likewise, rather than saying that the distance from Jupiter to the sun is 9 times this, or about 9 billion kilometers, we can measure its distances in AUs, or even Neptune, which is approximately 30 AUs, or 30 times 150 million, which is about 4.5 billion kilometers. Now, we know that within our solar system, we have a number of objects which we call a planet. And a planet is any large, round celestial object that travels around a star. Okay, so it has to go around a star. In our case, we call our star at the center of our solar system the sun. And so we have 8 planets which go around the sun. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now, Pluto is not a planet. Pluto is demoted. Okay? But the rest of them are. And a couple of them have interesting things, like, for example, rings. Now, we often only see pictures of Saturn with rings, but Saturn is not the only planet within our solar system with rings. Now, we call the 4 inner planets are rocky planets, and we call the outer planets, again, remember, Pluto is not a planet, it's a dwarf planet. We call them gas giants. Now, the reason that we do this is because the diameter of the planet in relation to the amount of hard surface and gas atmosphere is much larger in our gas giants than in our inner planets. Now, Pluto is what we call a dwarf planet. The reason Pluto is called a dwarf planet is because when they went and looked at the definition of what a planet should be, Pluto didn't meet some of the criteria. And the reason that they had to do this is because when they started looking at objects between Mars and Jupiter in our asteroid belt, we were starting to see objects that were close to the size of Pluto. And so as a result, they had to come up with a definition of a planet. The first one was be in orbit around the sun. That was fine. Have enough mass to be pulled into a stable spherical shape. Pluto is roughly spherical, not quite always. So this one was not quite met. And the other is it has to dominate its orbit. And the problem is that it crosses paths with other planets. So sometimes it's actually closer to the sun than Neptune. And also there are other objects in its orbit which are also relatively large. Now, we already talked, or I mentioned, that between Jupiter and Mars, we have what we call our asteroid belt. And then we also have other things in our solar system, which we call comets, and most comets come from further out in our solar system, out past Pluto. Now, asteroids are generally irregularly shaped. They're large. They consist of a lot of metal and rocks. Okay, and depending on their size, they can be planetoids or minor planets. Now, currently there are millions of asteroids in the asteroid belt between Mars and Jupiter, and they take somewhere between 3 to 6 years to go around the sun. And for the most part, they're held in a stable orbit around our star, the sun, between Mars and Jupiter, because Although the sun's pulling them in, the large mass of Jupiter is pulling them out, and this helps keep them there. But every once in a while, one of them will come in close and cross the path of the inner planets, and then we have to worry about them becoming meteoroids. Okay, they're traveling through space, and they can be the same size as an asteroid, but now what's happening is they're not staying within their main area. And then if they enter our atmosphere, we call it a meteor, and sometimes we call them shooting stars. And if a small part hits the ground of the Earth, we call it a meteorite. Now, there are two spots on Earth that are really good at looking for meteorites. One is Antarctica, because if you have any rock on top of the ice, there's a good chance that it came from above or from space. But actually, there's one that's much closer to you that you could find meteorites, and that's within your east troughs. If you have tiny magnetic pieces of rock found in your east trough, they might have come from space. Because otherwise, how would a rock get on your roof? Okay, now, these asteroids are leftover rocks from the formation of our solar system. And when all of the rocks were gobbled up to make the planets, anything that was left is what became an asteroid. Okay? And Jupiter, Trojan, our asteroids are being pushed or pulled by Jupiter's orbit. Some asteroids even have their own satellites. And we had this occur where NASA visited one recently. And we'll talk about this in the next couple of days in class. Okay? And meteor shower is just where we have lots of meteors entering Earth or crossing through the Earth's atmosphere. Generally, they're small and they burn up in the atmosphere before they have any chance to hit the ground. Now, we talked about asteroids. The other large thing that we will see often is called a comet. And a comet is basically a dirty snowball. It's just a chunk of ice, dust, and some rock all mashed up together. Okay, and what they do is they travel around the sun, and they are believed to come from an area called the Oort cloud, which is found beyond Pluto. Now, when the comets are going around the sun, they have two tails. They have what we call a gas tail and a dust tail. Okay, and it depends on what's happening. And so what happens is that as they're traveling through space, they're going to lose parts behind. Just like if you were to make a snowball and you didn't pack it together really well and you threw it through the air, you'd have pieces falling off as it's going through space. But the other thing that happens is if we have the sun over here and it's heating up and it's injecting its solar flares and its solar energy, what can happen is that can knock particles off. And so as a result, we get our second tail as well. Okay, so we have our dust tail, which is being left behind, and we have our gas tail. Okay,